Assalamualaikum and a very good morning. Happy Saturday, everyone. Welcome to our FAM online series, newly introduced in 2019 due to COVID. So we have managed to take advantage over the negativity of the situation. And now I believe that our online series is already in place with our technical team already quite independent to run the series on its own. Just a bit of introduction on our online series. The vision of online series is actually to function as a broadcast center, whereby we want, hang on, let me adjust my screen a bit. Something blocking. What we want is that the online series to function as a broadcast center. So that's why we fixed Thursdays and Saturdays as our broadcast time, so to speak. In season 1, we managed to cover 5 episodes. Now it's available on YouTube FAM channel. Please look up for it. On season 2, we have added 4 more series in extension of the 3 series that we covered in season 1. And of course, the series in season 1 is also continue with additional episodes for season 2. Example as our series today, Design for Fire. Today is our episode 3. So in season 2, we added 4 more series. So in total, we're gonna get 15 episodes up to August. The other thing to note is that all online series are recorded and the edited version is uploaded on YouTube channel. As I mentioned, season 1 is already uploaded. Thanks to our technical team and secretariat project officer, especially Nani helping on this. Okay. Without further ado, I would like to introduce our speaker. The topic today is designing for evacuation. It is episode 3 on Design for Fire series. In episode 1, we have covered firefighting from external, and in episode 2, firefighting from internal. And today we are now moving to internal. Yeah, Siong. So yes. we start to move internal or inside of the building. So the premise of this series is to discuss on the prescriptive UBBL, but also at the same time to caution or highlight areas of concern where in certain areas possibly require performance-based assessment instead of just completely relying on UBBL. So the series is moving towards that rather than just covering the basic requirement under UBBL. That's correct, Raj? Yes, yep. Lisa? You don't mind me referring to Lee Siong when we have this? No need formality.
No formality.
Yeah, okay, good. Architect Chong Lee Siong is a very familiar face to PAM events and series, especially on Design for Fire. But nonetheless, I would still introduce him. He graduated from Deakin University, Australia, many moons ago. He is now, he set up his company, Lee Siong Architects, soon after he graduated and received Part 3 registration, of course. He is now developed himself as an expert on design for fire, especially on architectural perspective. He is a member of Institute of Fire Engineers, and he has contributed to the drafting of UBBL. The current version is 2012, and he also contributed to the guidelines for Design for Fire, the Red Book, together with Jabatan Bomba. So on top of that, I have to note here that Architect Chong Lee Siong has produced or has presented many papers covering all sections in UBBL related to fire, design for fire, especially from architectural perspective. So that's why from Pam's point of view, he is considered one of our experts among others like architecture, shooting and all that. So without further ado, Chong, I'll pass it over to you.
Okay, I'll share my screen then.
Yes.
All right. Good morning, everyone. Glad to see you all again on this Saturday morning. I will just immediately share my screen. Good morning again, everybody. We have gone through many rounds in all our previous series of webinars and CPDs over the years. We have talked about all the aspects of designing for fire safety using the UBBL. For today, we only have 1 hour. What I intend to do is not to so much to go into the UBBL itself, because I think we are all very familiar with that already. And there are other avenues for us to revisit the technicalities of the UBBL and the technicalities of designing for fire safety, etc. But today, I just want to refresh ourselves to some of the fundamental concepts of fire safety, and in particular, the fundamental concepts of evacuation, and then leading to having some examples of what would constitute a good design. Very often we get ourselves so caught up with having to just to get our designs to be approved by the authorities. Getting things to be approved by authorities seems to be like the end in itself. You know, just get it to pass. And what do we have to do just to get our drawings to be, just to get our designs to pass the authorities and all that? But really, our design goes far beyond that. At the end of the day, what we are doing as architects is we are designing buildings. We are designing living spaces for people, living, working spaces for people. We are shaping our immediate environment. So really don't worry about the authorities. The authorities are just there. This is just, the authorities are there just as a check and balance. They are the gatekeepers to ensure that the things that we do meet the minimum set criteria. Yeah, but everything beyond that is for us as architects to work on and for us to improve, continuously strive to improve our designs and to make things a lot better, to be a lot more creative, and so on and so forth. Yeah, okay, but that's not the purpose of this this webinar. Right, let's very quickly go on to refresh ourselves on the basic concepts of fire safety. Yeah, we've always said that concept of fire safety, the most fundamental aspect of it is in evacuation. When a building catches fire, we won't want to worry too much about the building. The priority is not on the building per se. The priority is always on human safety, human life safety. So evacuation would be the primary focus on designing for fire safety. That's a fundamental of it. We start from designing for evacuation. Then that would, of course, be followed by passive containment, active intervention, and over the last two series of the webinar, we talked about access or firefighting and rescue. And just to recap again, items 1, 2, and 3 with regards to the UBBL, they are prescription based upon the purpose groups of a building, the nature of use of the building over the 8 designated purpose groups. And for fire safety, it involves prescriptions via schedules 5, 6, 7, 8, 9, and 10. Whereas for access for firefighting and rescue, we will find that the prescriptions in the UBBL are for all buildings, with references to the height and the volume of the building for all building types. Yeah, so there's this definition over here as to what is being prescribed in the UBBL, and which aspect of it that the UBBL is controlling, if I can use that word. The access for firefighting and rescue, as we've been through over the last 2 sessions, it really involves the physical accessibility into the building and the accessibility of the fire brigade and the bomber personnel, emergency and rescue personnel to the building to fight the fire both on the outside and to be able to fight the fire on the inside if the building exceeds a certain height and volume, right? But whereas when it comes to evacuation, passive containment and active intervention, it will have got a lot to do with the intended function of the building. How would the building be used? What are the things that are going to be installed in the building? What is the fire load of the building? What's the occupant density of the building? Yeah, and those items are then prescribed and put into, categorized into the purpose groups, the eight classifications of purpose groups of buildings. Today we'll be looking at evacuation, the very, very fundamental part of fire safety. Evacuation, again, we're all very, very familiar with all this already. Evacuation, it involves detection, alarms, exits, travel distances, all the various components that mix up the items above, and also very specifically about the capacity of exits. And the fundamental concept or the fundamental approach in how we do our design is that we'll have to make this assumption that there will only be one fire occurring at one location at that time. That would be the very basic assumption that we will be using for the purposes of our design. If you're designing a premise that has got a known risk, for example, if you're designing a factory, you're designing a production line, or you're designing a secured place, a high security place, say a prison or the American embassy and the US embassy, where there are known external threats to the building, yeah, then you'll have to make other assumptions or you have to make other provisions. Yeah, but in the absence of those very specific risks that we know in how we design our building, we will use this basis. And this is the basis in which the bylaws are written. And this is the basis that's used worldwide in our approach to designing for fire safety. That we are to assume there will only be one fire at one location at one time. And that one location could be anywhere. Right? You will have to, in order to test our design, you literally have to come up with a plan, blindfold yourself, point your finger at the plan and just stab on it and say, okay, what if a fire starts at that location, that random location that you picked in the building? How would the design function to cater for the evacuation, to cater for the containment, and to cater for the active intervention of that fire at that one random location? That would be the premise in which we're designing it. I'll share with you a very, very short video here. Okay, just to preview you, this video is extremely short. Look at the top of the frame over here. That one has got a time bar. It says 17:31. That's 17 minutes, 31 seconds. So just, oh, sorry, it's 17, that's 17:31 minutes and 37 seconds. It's starting at 37 seconds. Just look at the time bar over there. This entire video ends in 16 seconds, right? I'll just turn up the volume a little bit and I'll just play this video first. Father and child sitting there. Okay, that's 60 minutes of excitement over there. What the video showed was that it's a regular Saturday morning in a little apartment. A father and son is just lazing on the sofa. and they are charging their electric scooter. There is an electric scooter there that's plugged into plugged into the wall, and they're charging the battery of the electric scooter. So the first pop is the explosion. There was a little spark or a little explosion in the battery, and 16 seconds later, yeah, we got that very, very big explosion. I'll come back to that video later. In the UBBL, and also as elaborated further under the MS 1183, in terms of the classification of the purpose groups, they're broadly divided into this kind of category. In any building, the common state of mind of the occupants, and whether the occupants are familiar with the building, that means they are the regular users of the building, or they're unfamiliar with the building. That means there will be many, many visitors to the building, people who are just either visiting the building or just on a very short-term accommodation of the building. And the primary function or the primary state of mind of a person or of the occupants of the building when they're in there, are they fully awake and they're doing what they're supposed to do every day, or are they at the other extreme end? You're a patient in the hospital ICU, and you're totally sedated, and you're not aware, you're not even awake. Yeah, and from here, the UBBL places various types of buildings into various categories. And what it really does is that it classifies the risk, the risk of the fire, and also it classifies the risk that will be posed by the fire to the occupants. Obviously, if you look at this one here, look at the two extreme ends over here, the classification of an office. In an office, all of us are presumably the occupants of an office during the day. Presumably they're all awake, which they should be awake because they're working. They should be highly attentive, and they're at the peak of their peak of their emotional consciousness, because they're supposed to be working. You're supposed to be fully concentrating your work. So you're at the peak of your emotional consciousness. You're fully aware of your surroundings. And if that is your regular office, of course, you're fully aware of the environment that you're in. You know exactly which are the stairs that you're coming from, where's the main entrance. You know, you should be knowing where all your fire exits are, know where the fire extinguishers are hung, and know where all the little traps and the areas that are not supposed to go to. You're fully aware. On the other extreme end, if you're a patient in the hospital, in the ICU unit, you'll be heavily sedated, you'll be immobile, you may not have that sense of consciousness most of the time because you'll be sedated. You'll be relying entirely on nursing care, on other people to be able to move you around or whatever. Yeah, you'll really just be heavily sedated and lying in your ICU, on your ICU bed. So that one will pose the biggest risk. And at the other end of the spectrum, the office workers will pose the least risk. I'll come back to that later. Let's dwell on the nature of fire first. We are talking about evacuation in the event of fire. As we have seen from the video clip over there, fire starts. There will always be a point where there's an ignition, and the fire will grow and you'll develop, and you'll reach a full fire. And then after that, when the fire is really burning, eventually it will start to decay. When everything that's available for the fire to consume has been consumed, then the decay will start. There is this phenomena over here that we call a flashover. Indoor fire is very much like turning on your oven for you to roast your chicken. In that sense, you turn up the oven to a certain temperature, and the entire volume of air inside the oven would be reaching that temperature for you to be able to cook whatever it is that you're trying to cook in the oven. Likewise, an indoor fire in a contained area, if the fire is left unattended to, it will rapidly consume the fuel that's inside the fire. And you'll reach the point where the temperature in the room will be so hot that practically everything else in the room will start to combust. You will reach that point of self-ignition. And that phenomena is known as a flashover. And most fires, the lowest burning materials will probably start burning at about 200 degrees centigrade. And some of the more resilient materials will probably start burning at 400 degrees centigrade. And it's very, very often that internal unabated fire in a closed environment can go up to 600 degrees and beyond. And by that time, literally everything in there would be toast. For the situation in the video that we saw just now, it was 16 seconds. But that 16 seconds is not the flashover, right? That 16 seconds is really all the way down here, very early. It's called an untenable condition. Untenable condition means that it's no longer tenable for a person to remain in the room for even a short period of time. And human beings, we are very sensitive to heat. Just now when I talk about flashover, we're talking about temperatures 200 degrees, 300 degrees, 400 degrees, 600 degrees. No, we wouldn't want to be anywhere near there if when the temperature reaches that. Yeah? Our body temperature is 36 degrees, 36 to 37 degrees. If your body temperature is 38 degrees, you will already be having a very, very high fever and will be sent for COVID testing already. So the untenable condition to us is primarily the presence of smoke. Even before the heat hits us, it would be the smoke. When we are faced with smoke, we'll get asphyxiated, and most of us will not be able to hold our breath for longer than 10 seconds without gasping. So therefore, untenable conditions are reached very, very early in the life of a fire. In the little video that we saw just now, an untenable condition was reached from the ignition of the fire to the explosion of the battery in 16 seconds. Yeah, so that's how fast any given fire can reach untenable condition very, very quickly. So for designing for evacuation, we will be looking at just that small segment of the graph. Let's look at it again over here. So temperature and size. In the fire, there'll always be an ignition source, right? The ignition source would be an ignition source would, like in the video that we saw, the ignition was the battery. The battery probably had a short circuit, so there was a pop, and that's where the ignition started. And the fire will continue to grow until it reaches untenable condition. The time between the ignition of the fire to the point where the environment inside that particular room becomes untenable, it's in professional parlance known as the available safe egress time. Asset, that is your asset. In any given situation, in any given fire load, there is this available safe egress time, which we call the asset. In the example of the video, the asset was 16 seconds in that particular situation. So there will be the ignition, and once the ignition starts, when we design for evacuation, we want to get people to, we literally want to get people to get out of the building. So in order to get people out of the building, they have to go through there is this series of events that have to occur before the occupants of the building would evacuate from the building. We start with the ignition of the fire, and there has to be a detection. If the fire starts and there's no detection, obviously nobody will know that there is a fire. So you have to have a detection. From the point of detection to the point of raising an alarm. Raising an alarm is very much about the person either start to yell there's a fire in this room, or if the person is alone, he starts to make a decision himself, I think I better, or I confirm that there is a fire. So detection is very different from raising the alarm. Detection is just that you heard a pop, you hear a sound, or you smell a bit of a smoke, right? Then it takes a little bit of time for you to confirm that it is a fire, and that condition is a fire. Yeah. Then from there, there'll still be a little bit of a time before you can actually get people to start moving towards the exit, and there will be time taken for the occupants of the building to be totally out of that particular burning compartment. And this given time, and this time here is known as the required safe egress time, the reset. And under performance-based engineering approach, we would want to be able to calculate or to be able to design the building to allow a reset time, a required safe egress time of no more than 3/4 of the asset time. Right, this is to allow us that 1/4 of the time as a buffer, to allow for variables in the situation. So even when we do performance-based approach, we can only input certain data into the whole program for us to generate a simulation of the effects of the smoke and how fast the fire will spread and what's the smoke layer coming down and all that, to be able to ascertain the available safe egress time. Right, but all that data is really just numerical data. So if you put in X data, you will get X results, and then from there we can adjust it. We said, oh, we are looking for a Y result. So what do we have to do to get a Y result? Then we adjust the data, the input. Right. So the whole purpose of that would be that we will want to then design the building such that the required safe egress time would be less than 0.75 or less than 3/4 of the available safe egress time. And how does all this then link to the decisions we make into our design? It will be then to be understanding what's the purpose group of the building, and then referring back to the prescriptions in the UBBL with regards to what are the appropriate guidelines governing compartment limits, travel distances, the installation, the tent schedule, the installation of active systems and all that relative to the purpose group and relative to the size and volume of the building that we are designing, right? To cater for each of these each one of these components in our designing for evacuation. So under ignition, to lead to a detection, we have all these. Generally, this list is definitely not comprehensive. There are far more things to hear. But generally, we have the early detection systems. That's called VESTA. VESTA is a brand name, incidentally. A very early smoke detection alarm. We have the common smoke and heat detectors. We have the active suppression systems. Active suppression systems are like your sprinklers. Yeah, the moment they are activated, the active systems actually start to put out the fire already. They are already into the suppression mode. But the activation of the suppression systems also activates the alarm, right? So that are also part of the detection system in that sense. And on the human scale, smell, sight, and noise. Yeah, this is where we rely on the people, the occupants of the building who are in close proximity to the fire. We will be relying very much on the smell, sight, and noise, for them to detect the fire. That's the process of detecting a fire. Then when we go on to the alarm, if you have a very early smoke detection alarm system installed, these are generally installed in, say, computer rooms, in servers, in places where there are very low human occupancy, or in confined areas, like say in a raised floor of a semiconductor production facility, where you have a lot of services running under a raised floor or above a walkable ceiling, above the air plenum. You won't have occupants in there at all times, but there are sufficient volume and equipment and things in there that would potentially be able to catch fire. So we do install very early smoke detection systems in there. And these things will raise what we call a pre-alarm. Right? This is to avoid having an immediate alarm triggered. There could be false alarm and all that. That's a very, very big risk when you trigger a false alarm in a lot of high security or high sensitivity areas. We don't want false alarms. Right? So very early smoke detection systems, they will trigger what is known as a pre-alarm. And smoke and heat detectors also trigger alarms, and these will usually go through it's either a single knock system or a double knock or even a triple knock, depending on how much sensitivity that we require to the alarm systems. Active suppression systems, as I mentioned, the moment it's activated, it in itself would trigger the alarm. And then we come to the human component: sight, smell, and noise. If you're the person nearest to the fire, you're the person who first detected the fire, it would be up to you as the person, as a detector, the human detector, to also become the human fire alarm. And you can either manually trigger the alarm. If the building is equipped with those break glass or those alarm systems, can manually trigger it, or you literally become a human alarm. You yell at everybody in the room, fire, fire, get up. Yeah. So that's the human part of it. And once it's determined that there really is a fire and the alarm is raised, the immediate next step would be, we call it the movement. So you have to get people to go out. And people to go out of the building, especially in high public areas or in buildings with a lot of people. How do you go out? Okay, if there are a lot of people, you generally get directions, say, via the public address system. And this is especially important if the occupants of the building are not near the fire. They are not in visual sight of the fire, nor are they able to see the smoke, nor do they know where is the fire. The fire is probably in another part of the building, another compartment, and the building has to be evacuated. So these people will have to first they'll hear the alarm, then second they'll get the directions, very likely by the public address system. You have to move. This is an evacuation. It's not a drill, etc., etc. Better would be directions by the emergency response team. In a lot of large campuses or large buildings, large commercial areas, you will need to have the emergency response team consisting of either trained personnel to respond in the event of emergency, for them to give directions to the building. More often than not, you'll be basically following the herd. If all your colleagues are working in the same office, you hear the alarm, you hear the public address system. Everyone looks at each other, then everyone continues back with the work and ignoring that. Very likely you'll probably follow that as well. You will not do anything. However, if one single person panics, the person says, it's a fire, I'm going to run. He just grabs his things and he runs off to the fire exit. I bet you everybody will start to follow, right? That's called the follow the herd mentality. And last but not least is coming back to the individual. You have to follow your own instinct. Do you want to follow the herd? Do you want to obey the directions via the public address system? Are you the one taking the lead, or are you the follower? And all of that will eventually lead to the final exit, the refuge area, or in a worst case scenario, you'll still be stuck within the building way beyond the reset time, and worse, way beyond the exit time. The UBBL, under evacuation, two primary specifications have to come in. One is the prescription of the maximum travel distance. And the other one is the calculation of the occupant load, which directly then links to our design of the capacity of the exits. Whether you will have very, very wide exits or you can do with narrower exits. Yeah, so these two items here, the limits of the travel distance, how far can you travel as permitted by the UBBL for you to reach a final exit, and what is the minimum required width of the exits that we as architects have designed for. Coming back to this diagram over here, you will find that the prescriptions of the travel distance is directly related to the classifications of the building in the respective purpose groups. For example, offices, as you mentioned earlier, it's considered relatively low risk. The occupants in the building are supposed to be alert, they're wide awake, and they're fully familiar with the building. So we will make that assumption that the occupants of the building would be able to travel quite fast towards the exit of the building. Yeah, they're in the position to run probably, and they will know exactly where to go. There'll be no confusion. They will not be making wrong turns or getting trapped in dead ends, etc., etc. So the permitted travel distance is a lot more. Whereas in hospital inpatient and all that, obviously movement will be a lot slower. So you'll be exposed a lot longer to be within the building before you can reach an area of refuge or before you can reach the final exit. So therefore, the permitted travel distance is much shorter, as you see over here. And the same thing goes with the specifications of the exit capacities. These numbers here are persons per unit, as we all already know. Persons per unit, 1 unit, 550 millimeters of exit width. So again, for officers where people are in a position to run or to move and they're highly alert, you can pack more people to go through the exits in any given exit width. Yeah, whereas in hospitals and in high hazard factories, for example, the capacity of the exit width is very, very limited. It's limited to only 15 persons per module as opposed to 60 persons per module. What this one immediately means is that once you reduce the capacity, once the capacity per exit width is reduced, you will have to then, of course, design much wider exits, or you have to provide many, many more exits to be able to accommodate the slower efficiency of the movement of people out of the building. Right, that is the immediate correlation between the UBBL prescriptions and the analogy and the analysis of the risk posed by the occupants. Now, in a situation of a fire, common behavioral instincts. When you're faced with an adversary like this, there can only be two reactions, really. There's only two ways you can respond to an adverse situation. One is to fight, get a club and start clobbering the fire, or in our case, if you're confident the fire appears to be very small, it's a small waste paper basket fire from a burning cigarette, grab a can of Coke and throw into the waste paper basket. That will put out the fire. So you can fight. But really, most times, the adversary is something as huge and fearsome as this wolf over here. We would want to flight. In other words, we will want to run away. And when we're designing for evacuation, we are looking very specifically at the human response when we are in flight, when we are running away, when we're turning our back away from the adversary. Why do bugs fly into lights? When we are, as human beings, and we are running away from an adverse situation where we're in flight, in this case from an indoor fire, for example, the immediate thing we choose, instinctively, we would want to go back from where we came from. If you have entered the building by a particular route, you would instinctively want to reverse the route that you took to enter the building. Yeah? So you exit the building via the reverse way. In other words, going back, retracing your path as to how you entered the building, right? That would be the very, very first instinct of everybody, really. Don't talk about where the nearest exit is, right? There can be a door facing right in front of you, but your immediate instinct would be that, oh, I came through a front door and the front door is just over there. I turn left at the corridor when I came in, right? So now I'll retrace back and I'll turn right at the corridor. Yeah, it is to retrace the route from which we enter the building. Then this will be followed by brightness over darkness. Instinctively, we want to move towards brightness over darkness. Brightness, why? Because we can see better. That's the instinctive behavior, instinctive choice. If the situation is dark, if it's filled with smoke, we are not familiar with the building, we are not certain. There's this fear of the unknown. So therefore, we instinctively look for light. Yeah? Light is sunlight. We would veer towards brightness over darkness. And we would definitely be choosing open air over enclosed areas. Situation of fire is like in an oven. If you're in an oven, you're in an enclosed area. That's where the biggest risk is. So you turn your back away from an adverse situation. You will instinctively head towards an open air situation. You would choose, when faced with the choice of doorways, people will choose an open doorway over a closed doorway. It takes a lot of effort to have to push open the door, right? If a door is already open for you, you can see right through the door and you find that, oh, there's a clear path behind that door. You would instinctively choose the open doorway over a closed doorway. And if the doors are closed, you would naturally choose a see-through door over a solid door. Again, there's this fear of the unknown. What is behind that door? I can't see what's behind that door, right? Whereas if the door's got a view panel or if the door is a grill, for example, you can see right through it and say, yeah, okay, I know exactly what's behind it. And there's brightness behind that door. Yeah, that's where I'm going to go. Right? That's the way it works. And ultimately, what we are always looking for when we're exiting a building in any given situation is that we are looking for the light at the end of the tunnel, and we are rather subconsciously guided by the light at the end of the tunnel. So we are looking for the light at the end of the tunnel. And when we see the light, it may not be the end of the tunnel, but when we see the light, we would naturally want to go towards that light. Yeah? This is a situation. If you're faced with one path of travel and it's absolutely pitch dark in there, it could be pitch dark because the lights are turned off, or it could be pitch dark because it's filled with smoke. You wouldn't want to go in there. Yeah, you'll hesitate. Of course, if the fire is not imminent, you're not immediately, you don't immediately see the fire and don't immediately face the smoke, but you have to evacuate. You're given the directions to evacuate and you're faced with this corridor. You would really, really be hesitant because you don't know what's behind this place. You don't know what's within the darkness of this corridor. Is it an exit? Is it a dead end? Or is there someone lurking in there that's going to harm you? This would be a slightly better situation in a corridor when you lead towards the end. You see a glass door, you would, yeah, very likely choose the glass door over these other doors because these ones here can see that it doesn't really lead to anywhere, whereas that glass door you can see through it and you say, oh yeah, it leads to a flight of stairs. So yeah, probably that would be the exit. Well, in this case it is because there's the keluar sign there, right? This would definitely where you will run towards. You can't even see the keluar sign because the backlighting is so strong, but you would need a keluar sign to tell you to run towards there. You would want to go there. Even if it's not the keluar door, you would actually end up over there. Yeah, because that would be the natural instinct. You want to go towards the light, you want to go towards the outdoors. In common situation like this is all very nice and clear, very general. This is where you enter the airport. This is where you exit the airport. And even when you're first time arriving into the place, it tells you that this is the exit. So it's very easy. And if there's a fire, you naturally gone through it. People will say, yeah, it makes all these little keluar signs kind of redundant, really. Yeah, but I beg to differ, because keluar signs here, there is the one specification on the keluar signs that it has to be illuminated. Right, the illumination has to be maintained throughout the entire life of the keluar sign. So if in the event of a total darkness, the event of the total electrical shutdown, in the event of an emergency, these keluar signs will be the ones that will still be lit. And this one will then give you the directions to where the exits are. In a facade like this, where they're all glass, really you can't tell where the doors are, can you? Right, when everything is closed. This is actually a sliding door. Right, but there you have the two swing doors on both sides over here, and they're all listed as part of the emergency exit. So yeah, you would need these illuminated signs to guide you to where the door actually is. Yeah, but from afar, there's no mistaking where's the exit. A slightly more ambiguous situation. There are no swing doors over here. It doesn't really look like a doorway over here because it looks like part of the glass, slightly reflective. So on the inside, you don't see too much of the outside. You see a lot more reflection on to the inside of the building than to the outside. But it is an outside, and if this is the main lobby in which you came in from, you would instinctively want to go back out here. Hope that the sliding door works in the event of in the event that you do need to get out. And of course the keluar sign is there. And an intermediate pathway dividing two separate areas. The final exit is probably right at the end of the corridor over there, because it looks like outdoors. You can see a lot of light. In this situation like this, you may or may not know if this is a door. You may think that, oh yeah, these are windows, they are glass panels. So there's no door over there. I can't reach that final exit over here. Right? So you do need to give some assurances to the people. Yes, this is an exit. Do come over here. But it's a wall, it's not a door. Oh, come here, push it open because it says an exit over here, right? So do tap on the door and see if it opens. Of course, this one should be installed as automatic sliding for you to exit. There's no ambiguity at all in this particular situation. Bright streaming light coming in from the outside, the outdoors, at the end of a long corridor. No ambiguity. Instinctively, you will be running or moving towards this light over here. And there's a reassurance by an oversized exit sign, an illuminated exit sign that's bright enough to counter effect the bright sunlight that's coming through here. And it's big. It's really, really huge, much bigger than the standard sign, so that you can see it right from the other end of the corridor. So absolutely no ambiguity. Please come into this. Please come here. This is where the light is. This is where the final exit is. Similar to a situation like this, you see a lot of light streaming through here. And there's this green thing over here that indicates an emergency sign. So yeah, do come over here. However, if you are designing a situation like this, you have to be a little bit careful, to be mindful of how our layout would affect human behavior, would cause possibly a wrong interpretation of the space. Yeah? If people see this sign from afar and they see this light coming through here, most people will run straight through here. They may miss the fact that there is a door over there and that is a proper fire exit. This is actually a dead end going into two individual hotel rooms, yeah, whereas this is the fire exit. Right? So clarity of signage and how we do the layout of our building is very, very important. Most of these things would, of course, work on plan. If you just check your plans, you check your dead end distances, you check the coverage of the location of your fire doors and all that, most of this will probably work. But in an actual environment, in a 3D environment, after you install all these things, yeah, do be conscious and cognizant of natural human behavior and how they run and how they perceive things. So here you can see that actually signages are very, very important. Like we have a situation here where this is obviously, instinctively, we'll think that this is a final exit. But the actual exit is behind a solid door and the door is closed, right? So that one would take the greater precedence over this as far as human instincts are concerned.
Siong, we have 10. Siong, you have 10 more minutes or under.
Okay.
Yeah.
Okay, great. We're wrapping up. Right. With the situation like this, an open door is always more welcoming than a closed door. But of course, you'll say, yeah, but if these are fire doors, they're supposed to be kept closed at all times. Yes, that's true. That's true. Yeah, but there are also mechanisms to keep a door open during regular usage and electromagnetic mechanisms to close the door in the event of the fire. So, yeah, these are the things that can make a difference when push comes to shove. Yeah? An open door is more inviting. You naturally want to walk through an open door as opposed to trying to figure out which door to push open in this situation over here. When in doubt, yeah, just add in more signs. More signs is better than none when a situation calls for it. You would really want to avoid having your designs built in this manner where there's just so much ambiguity as to where is the exit. Right, during the construction, you can see that that one used to have a keluar sign over there, but now the keluar sign is rebuilt over here. The door doesn't say anything. There's no push bars. Nope, this is definitely not what you would want to be associated to your name. Clarity of purpose is also very important, where, like as I've always said, an open door leading to the light is always more welcoming than a door that's closed and shut, without any obvious means of opening. Ambiguity like this is very common in our country, as you can see. No entry in a keluar door. And where is the exit in this situation? Big sign that says exit here. So you follow the sign, you come up to here, say, where in the world is the exit door? I plugged this this photograph from a website that's selling printed stickers for doors and walls. Yeah, so they're proudly promoting that you can disguise a door to make it look like a cabinet. You wouldn't want to do this for an exit door, right? That was what the door was before, nothing great, but at least you know it's an exit. You can see that there's a push bar here and you know this is an exit door. There's a view panel here that you can see through. But when you stick it in a sticker like this, you're camouflaging the exit. No way, this is not what you want to do. In signages are also very important. Shopping complexes are totally overwhelmed with signages of everything. So emergency signages tend to get tend to be overshadowed by all the other signages and the bright lights of a shopping complex. So in the emergency, you'll see this illuminated sign here. There's some icons of people over there with the arrow. So yeah, you run it and you follow that to the exit. Be very careful that those are in fact emergency signs that lead you to an exit. Otherwise, you may be leading yourself in the toilet, like exactly in this case over here, is bringing you to the toilets. The floor markings in very large areas, floor markings are extremely useful. I find that floor markings are not used very commonly in our country because they're actually not mandated by the UBBL. Yeah, but really floor markings are very useful. I apply a lot of these on the large factory floors. Yeah, where we like in this case over here, we have very clearly demarcated areas for exit pathways in large factory floors. The ceilings, the roof of factories are usually very high. No way we can hang in a sign from above. And floor markings are really very effective in demarcating the areas of exit. You can also have a lot of fun with exit signages. This is actually a signage for one of the activities within this building. Yeah? So it's very well incorporated into the mandatory exit sign. Right? It enhances it rather than giving any contradictory messages. This is an example of an exit in Stockholm, Stockholm mass rail transit, the underground station. Very well done. This underground station is renowned for its grotto effect. They literally dug it under the cave and they built an underground station in there, and they left the cave-like architecture, cave-like structures as a ceiling. Everything is very gray, very earthy, and where the exit is bright red, so you can't miss it for anything else. And when you arrive there, there's no question whatsoever where the doors are, where you're supposed to push open the door. And of course, they have the mandatory illuminated exit signs. Because at the end of the day, all we really want is to be able to get our occupants to the light, to the final exit. No matter what the quality of the final exit is, we just want them to, without ambiguity, to naturally lead them to the final exit in the event of the fire. So in case of fire, please do exit the building before posting anything on the social media. And I thank you for your attention. Thank you. Pass back to you, Sophie.
Okay, thanks Lee Siong. That's covering on the exit, mostly on exits, exit doors and exit passage, right? We have a
yes, that's right.
we have a few questions, quite a number of questions from the Q&A.
Okay.
Before we move to that, I have a few questions for you. Maybe we warm up with that first.
Okay.
In 2 weeks or 1 week ago, 2 weeks ago, we actually covered online series on self-regulation with Dato' Izumi and Tan Sri Esa. That's quite enlightening actually. There's a proposal by Dato' Izumi, not under PEM but under Pemuda, if I'm not mistaken, to adopt, for the local authority to adopt self-regulation. His argument is that currently we have already practiced self-regulation under CCC, whereby there's risk, technically there is no change in our responsibilities and liabilities as architects when it comes to CCC. So he's suggesting that why not expand that self-regulation that we have done on CCC and extend it to the earlier part of building process or development process, which is submissions of plans, and that technically is just a paperwork, you know, submission of KM and building plan. So his proposal is that on submission of KM, it will be for areas with approved or gazetted development plans or gazetted structure plans or local plans, then the submission of KM should be automatically approved if the submission is already in compliance to that gazetted plans. And in the case of building plans, the professionals, the PSP or SP already make a declaration on responsibilities, then there is no need for another party to endorse it again. So again, he's proposing an automatic approval on building plan submission as well. So in view of fire submissions to Jabatan Bomba or design for fire safety and prevention, what is your take on this? Do you think that we professionals are ready to go for self-regulations, looking at the benefit of this self-regulation because of time saving? What's your view on this?
The principle of having the authorities and the professional is that it does act as a check and balance. We'll all have rules and regulations that govern anything. In our case, we've got the UBBL, the Architects Act, and all these things to ensure that certain minimum standards are met and is turned into a law, so that by law, when you profess, when you're in a profession, in doing that thing, by law you have to meet that minimum criteria to qualify as a professional. Right? Is the society's way of ensuring that the society is not shortchanged. Right? There is a measurable benchmark for that. Authorities, I see them as a gatekeeper. Yeah, we've always said it very, very clearly. Authorities are not responsible for our work. We are fully responsible as assigning professionals. But however, authorities are like the gatekeeper of the standards. You do what you have to do. It passes through the gate, and the authorities apply certain procedures to vet through what you've submitted to say, okay, yeah, it meets the standards. Okay, done, passed. You can go through it. I'm fully in support of self-regulation. Why? Because we are the professionals, and we know our stuff best. And as professionals, especially in an institute, that's what we are. The professional institutes are for us to learn, to develop the standards. Standards are developed from our learning, from our creations. That's why standards cannot remain over there. The UBBL was drafted way back in 1984 and is based on old British ordinance. So over the years, we have tried to upgrade the standards. As we learn more and more, as we improve our own knowledge, we contribute back to the standards and try and raise the bar for that. So yeah, definitely we should be self-regulated. But however, we are talking, when we talk about the professional, a professional body, when we talk about the profession, we are talking about a body. But the body are made up of 1 billion individuals here. Okay, like in PAM is Malaysia is about 2,000 over architects. So 2,000 over architects make up this body that we call ourselves as professionals. Currently, currently the authorities are the gatekeepers. They may or may not be as qualified as we are or as knowledgeable as we are, but they are the gatekeepers, they are the administrators. You do what you have to do, they go through there, a certain procedure to check it, to ensure that it meets the standards. It goes through there, it doesn't meet the standard, it throws it back at you and say, hey, you are the professional, fix it. So if you have to remove that, which I thoroughly support, but before we reach that stage, I think we as a professional, we have to come up with our own system of how we're going to check the work of our professionals. It has to be a very, very robust system, right? While we fully respect every single one in our profession, when you pass through part 3, you have really gone through all the checkpoints. Now you're in this profession, hey, now we are in full custody of our knowledge. We're in full custody of what we built for the public. We're in full custody of developing our own standards. We're in full custody of raising our own bar to give the standards back to the public. So yeah, I'm in full support of self-regulation, but we must ourselves as a profession come up with that
okay, I think
protocol.
Yeah, I think that that's a fair suggestion. Is that until the major barrier is actually for us and the profession, the individual and the profession, to question ourselves whether we are able to ensure that everybody in the profession are able to meet up with the expected requirement or expected bar that you said. Until we are assured of that, or whatever means that we have, the system would still need authority as a gatekeeper to remind us on our responsibilities and our obligations. I think I'll hold on to that. And the second question is very much related to that. We, under practice committee at PAM, we received a request from, or information from Jabatan Bomba from our meeting with them, is that they are under pressure by KPKT because of to meet their KPI. So their KPI are affected because there's a delayed approval process of firefighting plan submissions. And admittedly, they say that there are possibly some weaknesses on their side, but some of the contributing factor why the delay in approval is because of the quality of submissions by the submitting person. So to overcome that, they are now suggesting to have a merit listing of those architects, you know, who manage to do proper plans will get 5-star, 4-star, whatsoever. And this is to encourage for PSP or SP to improve their quality of drawing submission. And second proposal is for them to conduct training, special training for PSP and SP. What do you think of that in a short answer? Do you think it's a good idea? We should take up that as an opportunity to collaborate with Jabatan Bomba?
Yeah. I'll have to split my answer to two parts. I'll say yes immediately to working with Bomba to come up with collective with a, I won't call it a training program. I would call it as continuous professional development. Yeah, for both the practicing architects and all the Bomba officers. Because if they want, I mean, they are the gatekeepers, and we wouldn't want the gatekeepers to be any lesser knowledgeable than we are, do we? We don't want to have someone, you don't want your examiner to be less qualified than you are, right?
Yes.
So I definitely would say yes to that. That is something I personally have been trying to push forward, but again, due to the lack of time, I better not say too much on that one. Yes, definitely I'll say yes to that. On the second part, on the merit system, it comes back to the same thing again. We have our the gate checks that we currently already have under Architects Act and all that is already so rigorous. When you go to part 3, we expect that you're already there. You're qualified to be a practicing professional. Why do we have another person not coming along and grade us? We can't do that. And the worst part is, what are the qualifications of the people who are going to grade us? It will be the same Bomba officers whom we are dealing with every day. We are tearing up our hair every day dealing with them. I have to say, okay, it's not all, it's a 50-50 thing, right? Bomba, they do have the deficiencies. We as professions, we as a professional, when we submit cleansing, we do have our deficiencies, right? So
yeah, I totally agree.
Blind if that's the case. So I definitely disagree to the merit system. We must attack the elephant in the room. The elephant in the room is about first determining exactly what are the criteria. Right? Bomba as the gatekeeper must know what are the criteria. We as the professionals, not only do we have to know what's the criteria, we have to be the custodian of the criteria. In other words, we have to fully believe in it. Everything we do, that is how we are doing it, because we are the professionals. And that is our standard that we set first. Then we tell Bomba, that is the standard we set for ourselves.
Yeah.
Right? We have to train you to recognize that standard.
Yeah.
Then yes, I'll gladly have you take the role as the gatekeeper, because it helps us to weed out our own inadequacies.
I agree to that. I think the way forward for it is actually to have some sort of professional development, training, or recap, or retraining, something like that, and have a common platform, so that under this course, formal course, then we can set the criteria of the submission which is consistent, and set a common understanding of the interpretation of UBBL. So it requires both parties to set onto this common platform to achieve it. I think I totally support that. And as far as I know, from as a council member, PAM council member, I think PAM's position is that we will maintain our registration only with LAM. We do not support any other registration with other bodies. So I agree with you on that opinion. Okay, so shall we move to questions by the participants. The first one is, I don't know whether you can see it from there, but I'm reading the question from Mr. or Miss Lu Taining. Morning, Architect Chong, is it a must to comply all the comments as suggested by the fire authority, which is beyond the UBBL requirement? Example, fire officer suggested to increase fire resistance period from 1 hour to 2 hours on structural steel truss. What do you think?
That's precisely what we were talking about just now with regards to the training and the role of the gatekeeper and all that. Is the role of the gatekeeper supposed to be the tutor or the advisor? Or is the role of the gatekeeper just to check through the checklist and ensure the minimum compliance? And we leave the discretion to the architect. These are precisely the things that does happen. Okay. Of course, assuming that the bylaws has been interpreted correctly, and you are very, very clear that the fire rating required for that particular component is 1 hour, you can make your stand. You can make your stand on that. But however, as you've seen in my last three webinars, the bylaws doesn't actually addresses everything. The bylaw is just a set of basic bylaws, right? We as the architects we have the privilege of making the discretion on what to improve or what to design appropriately. Now, very much again, I always use the thing about the speed limit on the plus highway. The speed limit is 110 kilometers an hour. So you have every right to drive at 109 kilometers an hour on the highway, constant speed on the middle lane. You have every right to do that. You're not breaking the law at all. The policeman cannot stop you and say, aha, why are you driving 109 kilometers an hour? You should be driving 120. But you say, oh, but 120 is breaking the limit. Or the policeman will say, no. Today I decide that you should be driving at 80 kilometers an hour. No, really, the policeman can't do that because the law says you are permitted to drive at 110 kilometers an hour. But however, if it is a tropical thunderstorm at that time, it's raining 400 millimeters of rainfall in 5 minutes, the roads are flooded, and you are driving at 109 kilometers on the highway, you would be very, very foolish. Yeah, because your car will be aquaplaning. You'll be floating like a boat. The policeman can't catch you by law because you are permitted to drive 110 kilometers an hour. The law does not say that in a thunderstorm, you have to reduce your speed. See? So this thing does happen every day. The way I deal with Bomba is very simple. I really must know my work. Yeah, if Bomba does come up with what I think is a silly suggestion, I will be going back to them and say, let's talk about this. Yeah, let's talk about this. Yeah. Because I do apply my own work anyway. A lot of things go beyond the bylaws for the simple reason because we analyze it, we really look at it and say, yeah, the bylaw says that good, that's only the basis. Yeah, but over there and there, oh, you have to do this, you have to do that. We add a lot of things in there for purposes of improving the design. So yeah, in all these discussions, it is not so much of a question whether must you follow Bomba or not. Currently, they are the approving authority. If they decide not to stamp on your drawing and they give you your approval, you're not going to get your approval, are you? So it's very much about how you deal with them, how you talk with them, how you discuss with them, and to arrive at something that
common understanding.
Because like I said, they are the gatekeepers. Their job is to stamp.
Yeah.
And no matter what you say, you need their stamp. Yeah. So you are the professional. It is your design. Yeah. You convince Bomba that what you've done is right. Yeah. As a professional.
Yes, yes. I think it's almost like it's a duty to actually bring both parties to a common understanding of the correct interpretation of the law. But of course, it's easier said than done.
It's easier said than done, definitely. And that's why it comes back to what you mentioned just now, that if we're going for this training program, it really should be for both. Together.
Yes.
No different levels, not starting intermediate level for Bomba officers and we go on to professional level. No. they sit with us, go through everything we go through together.
Yeah. The second question is a bit more technical. Referring to 7th schedule, there's a note saying the width of an access to exit should be at least 700 mm. First question is, can you please explain what's the access to exit refer to? Is actually the term used. And second, does it mean in the application of PG1, normal housing, where it is not guided by the calculation in 7th schedule, the minimum width of all doors and stairs shall be 700 mm? Actually, it's quite, I mean, UBBL interpret that clearly on the minimum unit width.
I do not know what is PG1. Sorry, I may have missed something out there. PG1, I'm not particularly sure what is that one referring to.
I'm not quite sure.
But never mind. Well, since it says about normal housing where it's not guided by calculation of 7th schedule, that would be a bit strange.
Purpose group 1, actually, I think.
Oh, purpose group 1. Okay, residential. Yeah. Okay. Okay, the minimum width here, this one comes back to terminology. When we say exit, we are referring to the doorway or the stair or the ramp. Under the schedule, what schedule is that really? The one I just shown on the calculation exit width, it's clearly stated that horizontal exit, stairs, ramps, etc., etc., etc. Exit refers to that gate. Access to exit is, if it's internal, that means it's your travel distance. Anything covered within your travel distance. You can walk anywhere. Access to an exit is walking between your workstations. Access to the exit is walking between your internal partitioning. Access to the exit is walking in between the furniture that you place on the floor. That is access to the exit. The exit itself is that doorway. And it's either a final exit, a story exit, a horizontal exit, etc., as defined in the bylaws. Yeah? So access to the exit here, if it says 700, it means just that when you place your furniture, when you do internal partitioning and all that, when it's not forming the exit route. See, again, exit route refers to the protected route from a story exit or a horizontal exit leading to a final exit. That is the exit route. So all exit width calculations governs exits widths and exit routes. It doesn't, that calculation does not govern your internal layouts, i.e. your partitions, your rooms. It doesn't govern that. Yeah, so this is just an indication that if you are to use, okay, sorry. This one comes in for you when you calculate your travel distance, your direct travel distance. Say in an open plan, you use the 2/3 radius, that's fine. But when you start populating the internal plan, when you submit the internal plan to Bomba for the internal layout approval, you will want to then demarcate the travel distance. That's not the exit route, right? That's called the travel distance. Where are you measuring the direct travel distance to an exit? Right, okay, that one is where this one comes in. That you cannot demarcate your travel route. You cannot demarcate your travel distance to be like, say, diagonally across to a table from one corner across. Yeah, squeezing between a table that's less than 700 meters, 700 millimeters closer.
Yeah.
Okay, so this is not for the exit route. This is for your demarcation of access to the exit.
Okay. There's one question here, which is it's a common question that pop up every now and then on car park. How should we determine the occupancy load of car park? There is no provision under 7th schedule. The question here is that why is it not addressed? Possibly, I would prefer you to respond. Why was it not addressed in the latest revision 2012, knowing the fact that there's a gray area on occupancy load for car park? What's the reason for that, really?
Because the purpose group of car park is under storage in general.
But why not address it and correct it for once and for all? Right?
It is being addressed in the current revision. I can't reveal too much about that, but it is being addressed. There is a current one now that.
After 2012 now
yeah,
is
after
okay.
2012, very recent. But I can't say anything about that now because I don't know what's the status now on.
But maybe you can elaborate on the status of this occupancy load.
The general rule of thumb that Bomba is practicing now is you either use 2 occupants per car, or you use the immediate occupant load of if there's one single floor that discharges, or if this car park serves a particular occupant load of that building, you use that occupant load, or you use 2 occupants per car. That is a general rule of thumb.
Yeah.
It's a rule of thumb. It's not in the bylaw.
Yeah, so it depends on whether the car park serving a cinema or a car park serving an office.
That's correct. Yeah.
So a car park serving an office, you would imagine that on average it would be 2 person in the car. But if a car park serving a cinema,
it's either like, for example, your office, you got 900 occupants in the office by the occupant floor. The car park is only for the occupants of the office. Okay, you assume that if everyone drives a car there, somehow sharing car and all that, there'll be 900 people coming down into the car park at one time, right?
Okay.
Or you just use the general rule of thumb, 2 persons per car park allocated in the car park.
So in the case of cinema, then you have to calculate the total capacity of the cinema. And
usually it doesn't work out very well that way, because then you start to think, not everyone drives to the cinema. Now half of them take public transport. Then when we start to go into that kind of a breakdown, it just breaks apart. So rule of thumb, if you can't justify the actual usage, is 2 persons per car park.
But this gray area will be addressed in the current.
It's supposed to be addressed now in the current one, but let's see what the outcome is. We do not know what's the final outcome.
Because we
don't quote me
realize
on
this.
That, please.
We realized this like about 20 years already.
Yeah,
right?
Don't quote me on that, please.
Okay, no, I won't.
Yeah.
Okay, another question. Based on the presentation, this is my question actually. Based on your presentations, this time you did not highlight any gray area when it comes to evacuation. Does it mean that the prescriptions in UBBL now is already fully covered? In the sense that, is there any situation whereby we have to use performance-based criteria in our calculation for exits and the exit width, the total exit routes?
The only time when you use performance-based approach is that you have to start off with first your compartment volumes. If the compartment volumes exceed the limits, and the nature of the building, or the nature of the design is such that there's no physical means of breaking down the compartments to whatever to be within the limits, you would then have to go for a performance-based approach. And the performance-based approach would be primarily going on the simulation to determine what would be the asset time, the available safe egress time. And that would then come from the simulation of a given fire load within that compartment that you're designing, placing it in certain pre-selected areas to do a simulation, checking the smoke evacuation, the capacity of how you evacuate the smoke, controlling of the smoke layer, the smoke zones and all that, to determine what would be the available safe egress time. Then from there, we work back to the occupants, the type of occupants on the density of the occupants for that particular purpose group, and what would be the alertness level in terms of the occupants, what purpose group, whether it's office, shopping mall or hospital, that kind of a thing. Then from there, you simulate the exit time, how far they will be running, and how many exits are available. So you will want to then, the whole purpose of performance-based approach is to simulate, first to do a calculation on determining what is the asset time, and then whether what we have designed in terms of evacuation and travel distance, what is the design reset time. Yeah, that's where it comes in. So if for whatever reason if for whatever reason we cannot meet the prescriptive codes of travel distances and all that, and you'll see that there's whatever it is that you're trying to design is of such a high priority that that you wouldn't want to attempt to meet the prescriptive codes, then yes, you choose that option to go for a performance-based approach.
We almost at the end of the session now. Just to remind everyone, please stay on to the end of the session. You need not only sign-in code, you also need sign-out code, and also a link that leads to a questionnaire that you have to fill up and respond in order to complete your participation record for the purpose of CPD points. Let's take a quick question. I think this answer could be very quick. There is a restriction between final exit to external of building. If I have a staircase, which is the intermediate of a car park area where the final exit of this staircase will be more than 50 meters to external at ground floor and provide protected corridor, is it possible? Meaning that the final exit is actually within a space, so they provide a corridor, protected corridor leading to the actual final exit. Meaning that a final exit within a space is not called final exit, right?
We have the travel distance that's limiting the travel distance from any part of the room to the story exit or to the final exit. In a situation where you end your calculation of your travel distance, you have to end the calculation of your travel distance via a door. you go past either a horizontal exit, story exit, or a final exit. Your calculation of travel distance ends. So once you enter that exit, you cannot go back into the building. That exit will have to lead you into a place of refuge, or it'll be a protected passage all the way to a final exit. Yeah, so, and that route will not have any travel distance limitations. It's the same analogy. You exit from the 20th floor via a story exit. So you've gone past a story exit. Travel distance calculation stops. The distance that you take to run down the stair, you're in a protected environment. So there's no limit to what's the flight of the stair that you have to run down to get to the final exit.
Yeah, the question is that I think the exit route actually leads to a door that opens to a ground floor. It is not really to the outside yet. It leads to a ground floor. And from ground floor to the exit outside, it requires a 15 meters protected corridor. The question here is that, is it a must to do this protected corridor leading to the actual definition of final exit, where final exit is actually a safe area?
In accordance with the principle, it's yes. Yeah, just via principle. The whole idea of it is that you're only exposed to the fire within the permissible travel distance. Then thereafter, you're supposed to be isolated from the fire until you're out of the building, which is until the final exit. So if you put a final exit within the building, that is not a final exit.
Yeah, correct. Okay. I think that's the end of the session. That's all the time that we have for under this episode. We will have another episode under a design for fire safety. In 2 weeks' time, we'll continue with our discussion or conversation on a new topic or expansion of current topic. We're not sure yet. So thank you very much, Architect Chong Siong, for being with us today and sharing your perspectives and interpretation of UBBL.
Thank you.
We look
My
forward.
pleasure.
We look forward to have this as a permanent and continuous series.
Yeah,
and thank you again to everyone for supporting PAM online series. We hope to see you again. Our next session will be this coming Thursday on a series that we started in season 1, quality of completed buildings. We continue with episode 3. So hope to see you again this Thursday. Another announcement possibly, next Saturday, we have another interesting session, conversation with Pam, and this one with President Pam talking about professional practice post-COVID-19, the individuals, the firms, and the profession. What can we do to recover? Something like that. It's a conversation. So looking forward to see everyone there again. So thank you again. We are now signing off. Please stay on for the link. Over to you now, Salam. Bye.